This topic is about being able to expand brackets of the form x plus y to the power of n using the binomial expansion formula for natural numbers. We need to be able to also use the binomial expansion to find approximations. So the first thing we need to go through is the factorial notation. So the number of ways of arranging n objects when they are all different is denoted using the factorial notation, which is n factorial, like this. So n factorial, so when you're picking the first object out of n items, there's n ways of picking it. For the second object, because you've picked one already, that means you have n minus 1 choices. For the next third object that you pick, you have n minus 2, because you already picked 2 objects. Next one would be n minus 3, and you keep going down until you have 3 choices, then 2 choices, and then 1 item remains. So that is n factorial. Okay, so it's n times n minus 1 times n minus 2 times n minus 3 times ... times 3 times 2 times 1. A thing to note is 0 factorial by definition is equal to 1. Okay, just remember, so if you have n objects, all of them different, then the number of ways to pick them up or arrange them is n factorial ways. Okay, the next definition that you need to know about is the combination formula. So if there are n objects of 2 different kinds, and r of them are of one kind, which means n minus r of them are of the other kind, the number of ways of combining them is given by this formula. We could say n choose r, or we can denote it as column vector, like a column vector, n choose r. So you can either use the first way or the second way to express it. And the formula is n factorial over r factorial times n minus r factorial. So we say n choose r. Note again that n choose r is the same thing as n choose n minus r, since n choose r means obviously n factorial over r factorial n minus r factorial, but that's the same thing as n choose n minus r factorial times n minus r factorial, because this thing will just become n minus n, which is equal to 0, minus r becomes r factorial. So it's the same thing. So that means, e.g., 5 choose 3 is the same thing as 5 choose 2, because they're complements of 5 in the bottom. 2 formula now, so the n factorial formula, and we've got the n choose r. So let's just look at some quick questions on how to handle these things. Okay, so work out 4 factorial. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2 is 24, so that would be 24. Second example is 10 factorial over 7 factorial. is the same thing as 10 times 9 times 8 times 7 times 6 times blah 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 times 3 times 2 times 1. And 7 factorial is the same thing as 7 times 6 times blah 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 times 3 times 2 times 1. Now you can see you've got 7 times 6 times blah 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 all the way up to 1 in the numerator and the denominator. So you can cross it out. So all you're left with is 10 times 9 times 8, which is just 10 times 9 is 90. 90 times 8 is 720. So the answer will be 720. Okay. And if I do 15 factorial over 13 factorial, that is the same thing as 15 times 14 times 13 times blah 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 times 3 times 2 times 1. 13 factorial is 13 times 12 times blah 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 times 3 times 2 times 1. Cancel out all the common factors in the numerator and the denominator, which means all you're left with is 15 times 14. 15 times 14 is just 210. So that was the factorial notation, getting used to the net factorial notation. Let's get used to the n choose r now. So 6 choose 3 is equal to, using the formula, 6 factorial over 3 factorial, 3 factorial, 6 minus 3 factorial, which is the same thing as 6 factorial over 3 factorial, 3 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. All over 3 factorial is 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. And because they're next to each other, we're multiplying all of these. Now we can cross out 3 times 2 times 1 and 3 times 2 times 1 in the numerator and the denominator because they're common to both. 3 times 2 times 1 is 6. So there's 6 and a factor of 6 at the top as well. So all we're left with is 5 times 4, which is just 20. Okay, 5 choose 4 is 5 factorial over 4 factorial. 5 take away 4 factorial, which is just 5 factorial over 4 factorial, 1 factorial. 5 factorial is just 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And 1 factorial is just 1. So I can cancel out all of this. So all I have remaining is just 5. Next question is 10 choose 8. So 10 choose 8 is the same thing using the formula as 10 factorial over 8 factorial. And then it's 10 minus 8 factorial, which is 2 factorial. Now by now you should notice the 2 factorials at the bottom is this add up always to give the factorial at the top. So if it's, look at the first example, 6 choose 3 is 6 factorial, 3 factorial, 3 factorial. So the bottom here, the 3 add 3 gives you the 6 there. The 4 add 1 gives you the 5 at the top. So 8 add 2 gives you 10. So you should have spotted this pattern by now. So you can write that down straight away without having to write the first step. So 10 factorial is just 10 times 9 times 8 times blah 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 times 2 times 1. All over 8 factorial, which is 8 times 7 times blah 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 times 2 times 1. And 2 factorial is just 2 times 1. 8 times 7 all the way up to 2, so all the way up to 1, cancels out. So all I'm left with is 10 times 9 in the numerator over 2 times 1, which is 90 divided by 2, which is 45. There's one more to do, so let's write it out here, which is 9 choose 5. 9 choose 5 is equal to 9 factorial over 5 factorial. 9 take away 5 factorial is just 4 factorial. Which is the same thing as 9 times 8 times 7 times 6 times 5 times blah 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 times 2 times 1 over 5 times 4 times 3 times 2 times 1, which is 5 factorial, and 4 factorial, which is 4 times 3 times 2 times 1. So all that 5 onwards will be cancelled out with a 5 factorial at the bottom. And 4 times 3 times 2, so 3 times 2 can cancel out with the 6. And the 4, a factor of 4 can go from the top and the bottom. So all you're left with is 9 times 2 times 7. 9 times 2 times 7 is 18 times 7, which is 126. Okay, next question is a show that question. It's a bit more difficult. So n choose 1 is equal to n. You have to show that. So n choose 1. N choose 1 is the same thing as n factorial over 1 factorial times n minus 1 factorial using the formula. Now n factorial is just n times n minus 1 times n minus 2 times n minus 3 going down all the way times 3 times 2 times 1. 1 factorial is just 1. N minus 1 factorial is n minus 1 times n minus 2 times n minus 3 times all the way down to times 3 times 2 times 1. Now if you see there's a common factor of n minus 1, n minus 2 all the way up to 1. So I'm going to cross that out with all of this. So all I have remaining in the numerator is n, and the denominator is 1. So n divided by 1 is just n. So that was the answer to A. If I do B in a similar way, so n show that n choose 2 is equal to n times n minus 1 over 2. So n choose 2 is the same thing as n factorial over 2 factorial n minus 2 factorial using the formula. So if I write that out, that's the same thing as n times n minus 1 times n minus 2 times n minus 3 times blah 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 all the way up to times 3 times 2 times 1. All over 2 factorial is just 2 times 1. N minus 2 factorial is n minus 2 times n minus 3 times blah 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 times 3 times 2 times 1. Again, you can see what cancels out at the top and the bottom. N minus 2 onwards cancel out in the top and the bottom. So all I'm left with is n times n minus 1 in the numerator and 2 times 1 at the bottom, which is the same thing as n times n minus 1 over 2, which is what I was trying to show. Next question. Given that 50 choose 13 is equal to 50 factorial, 13 factorial, a factorial, write down the value of a. So this is the pattern that we're talking about before. So 50 choose 13 is the same thing as, using the formula is 50 factorial over 13 factorial and then 50 minus 13 factorial. So a is equal to 50 minus 13, which means a is equal to 37. So remember the complement of 13, which adds up to 50. Okay, so the next one is 35p is equal to 35 factorial, p factorial, 18 factorial. Write down the value of p. So I've got 35p. That by using the formula, that's the same thing as 35 factorial over p factorial and then 35 take away p factorial, which means that 35 minus p must be equal to 18, which means 35 must be equal to 18 plus p, which means p must be equal to 35 minus 18, which means p is 17. Okay, next one. For what value of p does p choose 2 equal p choose 3? Prove this algebraically. Okay, so p choose 2 is equal to p choose 3, which implies p factorial over 2 factorial p minus 2 factorial is equal to p factorial 3 factorial over p minus 3 factorial. So 3 factorial p minus 3 factorial, which means that 2 must be equal to p minus 3 and 3 must be equal to p minus 2. But if we arrange to find p for both these equations, p is equal to 5. So that is true. P must be equal to 5. which makes sense because 2 and 3, when you add it up, it does give you 5. Okay, B. For what value of P does P choose 6 equal P choose 4? So P choose 6 is equal to P choose 4 implies P factorial over 6 factorial P minus 6 factorial must be equal to P factorial 4 factorial P minus 4 factorial. Again, similarly, P minus 6 must be equal to 4 and P minus 4 must be equal to 6, which implies P must be equal to 10. Okay, now we come to the binomial theorem. So this formula is given to you in the formula booklet. So a plus b to the power of n. Now the important thing is n is the element of natural numbers. So n is a natural number, which means n is equal to 1, a positive integer, 1, 2, 3, 4. So any positive integer. So it has to be positive and an integer. It can't be a fraction. It can't be a negative number. Okay, then we can use this expansion to help us expand the bracket easily. So let's look at the patterns here. So if you look at the patterns here, first thing is a to the power of n. So it's the highest. The first term is at the highest power, and then do you see as you go along down this sequence, or you can call it series, the power of n is decreasing. So it's a to the power of n minus 1. This is a to the power of n minus 2. So it decreases all the way until this point where there's no a to a present. So the power of a is decreasing. If you look at the power of b in a similar way, and let's do that in green. Here, there's no power of b, but then the power of b is increasing as you're going along. So one of them increases, one of them decreases. Okay, and if you look at the choose function, so let's just use a choose function, there's actually an invisible n choose 0 here. Yeah, but you can see the first term has n choose 0, second term has n choose 1, n choose 2, all the way up to n choose n. Okay, so you got 3 parts to each term, yeah? So you have the choose part, you have the first term raised to a certain power, and the second term raised to a certain power as well. And throughout this, you have to remember what n choose r is, or you input into your calculator to work out what n choose r is for each one. Okay, so let's look at how to apply this in an equation, in an example. So use the binomial theorem to find the expansion of 2x plus 5 to the power of 3. So in this case, your a is the first term, which is 2x. Your b is 5, which is the second term, which is a positive 5. And n is equal to 3 in this case. So if I want to do 2x plus 5 to the power of 3, the first thing is I have to do a to the power of n. So 2x, which is the first term, raised to the highest power, which is n, 3. Okay, the next term is 3 choose 1. Remember, we decrease the first term by 1, so it becomes 2x squared. And we increase the second term by 1. The next term will be 3 choose 2. We decrease the first term by 1, so it becomes 2x to the power of 1. And 5 gets raised by another power, so 5 squared. The last term is 3 choose 3, which we don't have to write down because it's just 1. 2x disappears, and all we get is 5 to the power of 3. So if you realize n is equal to 3, but we always get 1 extra term, so there's 4 terms. So whatever n is, you always get 1 extra term. Okay, 2x cubed is 2x times 2x times 2x, which is 8x cubed. Be very careful. A lot of people just write 2x to the power of 3. Don't forget to raise 2 to the power of 3. 3 choose 1 is just 3. 2x all squared is 4x squared times 5. Plus 3 choose 2 is just 3 times 2x times 25. 5 squared is 25 plus 125. All we have to do is use a calculator to simplify. So I get 8x cubed plus 3 times 4 times 5, which is 60x. And we've got x squared there, so x squared. Plus 3 times 2 times 25, which is 150. And then we've got an x there. And then plus 125. And that will be the binomial expansion of 2x plus 5 to the power of 3. Use the binomial theorem to find the expansion of 3 minus 2x to the power of 5. Again, in this case, the first term is 3. The second term, be very careful with this, is minus 2x, and n is equal to 5 in this case. So when I'm expanding 3 minus 2x to the power of 5, the first term raised to the highest power, so it's 3 to the power of 5, plus 5 choose 1, so the choose function comes first, 3 to the power of 1 less power, so 3 to the power of 4, times minus 2x to the power of 1. Put a bracket around the minus 2x so you don't make mistakes when you start simplifying it. This next term will be 5 choose 2, 3 to the power of 3, minus 2x to the power of 2. Look at this. Each term, each of these powers always adds up to 5. Okay, so notice these patterns as you're going along. It makes your life easier and you won't make mistakes. Next term is 5 choose 3, 3 to the power of 2, minus 2x to the power of 3, plus 5 choose 4, 3 to the power of 1, minus 2x to the power of 4. And the last term is minus 2x raised to the highest power, which is to the power of 5. Okay, 3 to the power of 5, if you put that into your calculator, you get 243. 5 choose 1 is just 5. 3 to the power of 4 is 81 times minus 2x. Okay, so minus 2x to the power of 1 is minus 2x. Plus 5 choose 2 is 10 times 3 cubed, which is 27, times minus 2x all squared is 4x squared. Plus 5 choose 3, which is 10, times 3 squared, which is 9, times minus 2x cubed is minus 8x cubed. Plus 5 choose 4 is 5, times 3 to the power of 1, which is 3, minus 2x to the power of 4 is 16x to the power of 4. And the last one is minus 2x raised to the power of 5 is minus 32x to the power of 5. If I just simplify now, I get 243, take away because it's got minus 2x, so 5 times 81 times 2, which is minus 810x, plus 10 times 27 times 4 gives me 1080, and there's an x squared there, so 1080 x squared. Next term is 10 times 9 times minus 8, so it's going to be minus, and there's an x cubed present, so I get minus 720 x cubed. Next term is 5 times 3 times 16 x to the power of 4, which is going to be 240 x to the power of 4. And the last term is minus 32 x to the power of 5. Look at the signs in between the terms. It's alternating from subtract and add because obviously we're expanding 3 minus 2x to the power of 5, so it is alternating. So make sure your signs are alternating as well. Okay, use the binomial theorem to find the expansion of x squared plus 2y to the power of 4. So in this case, your a is x squared, your b is 2y, positive 2y, so you can just write 2y, and your n is 4. So x squared plus 2y to the power of 4 is x squared raised to the power of 4, the highest power. Then 4 choose 1, x squared decreases by power 1, the power of 1, and 2y appears. Next one is 4 choose 2, x squared decreases by a power, and 2y raises by an extra power. 4 choose 3, x squared decreases, 2y increases, and the last one is 2y raised to the highest power. X squared to the power of 4 is just x to the power of 8. 4 choose 1 is 4, x squared to the power of 3 is x to the power of 6 times 2y, plus 4 choose 2 is 6 times x squared times to the power of 2 is x to the power of 4, times 2y all squared is 4y squared, plus 4 choose 3 is 4 times x squared times 2y to the power of 3 is just 8y cubed, plus 2y to raise to the power of 4 is 16y to the power of 4. Okay, now we need to simplify. So I get x to the power of 6, so x to the power of 8, plus 8x to the power of 6y, plus 24x to the power of 4y squared, plus 4 times 8 is 32x squared y cubed, plus 16y to the power of 4. Okay, find the coefficient of x to the power of 6, y to the power of 6 in the expansion of 2x plus y to the power of 12. Now this is going to have 13 terms, remember, because n is 12, it's going to have 13 terms. So if you write it all out, we'll be there doing unnecessary work. So if I do like this, 2x to the power of 12 plus 12 choose 1, 2x to the power of 11 times y plus blah, blah, blah. I'll be there all day writing out a lot of things that I don't really need. So what I need to do is just look at this term. I need to find how I can make x to the power of 6 and y to the power of 6. So that means if I'm expanding, so we don't want to do it like this, yeah? So instead what we want to do is if I'm looking at 2x plus y to the power of 12, so we have a lot of terms at the start and we have a lot of terms at the end, but we don't care about them. So what we're looking at is how can I raise 2x to make it x to the power of 6. Obviously, I need to raise 2x to the power of 6 to get x to the power of 6. Which means because 12 take away 6 is 6, I need to raise the second term, which is y, to the power of 6. Which means I will get x to the power of 6 and y to the power of 6. So that's the right term that I'm looking at. All I need to know is what function what choose function that is. So obviously, because n is 12, that must be 12. Now 12 choose, because we've got 2x to the power of 6, it must be 12 choose 6. Okay, if I put this into the calculator, 12 choose 6 is 924. 2x to the power of, all raised to the power of 6 is just 64, x to the power of 6, and y raised to the power of 6 just y to the power of 6. And I just need to simplify it, which is, it gives me 59136 x to the power of 6, y to the power of 6. So the coefficient of x to the power of 6, y to the power of 6 is just the number in front of x to the power of 6, y to the power of 6, which is 59136. Find the first three terms in ascending powers of x, so that means increasing the powers of x, of the binomial expansion of 2 minus x to the power of 6 and simplify each term. So that means 2 minus x to the power of 6. So if it's increasing power of x, the first one needs to have no power of x. So that means it's going to be 2 to the power of 6 plus 6 choose 1, 2 to the power of 5 times minus x plus 6 choose 2, 2 to the power of 4 minus x all to the power of 2 plus blah, blah, blah. We only want the first three terms. We've already got the three terms. 2 to the power of 6 is 64, plus 6 choose 1 is plus 6, times 2 to the power of 5 is 32, times minus x, plus 6 choose 2 is 15, times 2 to the power of 4 is 16, times negative x all squared is just x squared. 64 is the first term. 6 times 32 times negative x gives me minus 6 times 32 is 192x plus 15 times 16 times x squared, which is 250x squared. I'm expecting the next term to be minus, but it doesn't matter. As long as I've got the first three terms, I'd get the full marks. Okay, next example, find the binomial expansion of x plus 1 over x to the power of 5, giving each term in its simplest form. Okay, so x plus 1 over x to the power of 5 is equal to x to the power of 5 plus 5 choose 1, x to the power of 4 times 1 over x. So decreasing the first term and increasing the second term. Plus 5 choose 3, x all squared, 1 over x all cubed, plus 5 choose 4, x times 1 over x to the power of 4, and the last term will be 1 over x all raised to the power of 5. Okay, the first term will be x to the power of 5. 5 choose 1 is 5 times x to the power of 4 times 1 over x, plus 5 choose 2 is 10 times x cubed times 1 over x squared, plus 5 choose 3 is 10 times x squared times 1 over x cubed, plus 5 times x times 1 over x to the power of 4, plus 1 over x to the power of 5. If I simplify this, I get x to the power of 5 is 2 my first term. I get 5, x to the power of 4 divided by x is just 5x cubed. 10 x squared divided by x cubed is just x. Next term is 10 x squared divided by x cubed is just 10 over x, because there's x left in the denominator. Next term is 5 x divided by x to the power of 4 is x cubed in the denominator, and plus 1 over x to the power of 5. And you can look at the pattern, you can see that the power of x is decreasing by 2. Okay, you also need to remember I said we should be able to approximate using the binomial expansion. So let's do a few examples of these. So part A, find the first 4 terms of the binomial expansion in ascending powers of x, or increasing power of x, of 1 minus x over 4 to the power of 10. So first thing is 1 to the power of 10, plus 10 choose 1, 1 to the power of 9, minus x over 4. So be very careful, it's negative x over 4 raised to the power of 1. So that's second term. Third term is 10 choose 2, 1 to the power of 8, minus x over 4 to the power of 2. And the last term that we need is 10 choose 3, 1 to the power of 7, minus x over 4 to the power of 3. Plus dot dot dot, which we're not interested in. Let me just change this to a 10 because it looks like a 16. Okay, so 1 to the power of 10 is just 1. 10 choose 1 is just 10. 1 to the power of 9 is 1 times minus x over 4, plus 10 choose 2 is 45, times 1 to the power of 8 is 1, times x squared, negative x over 4 all squared is x squared over 16, plus 10 choose 3 is just 120, 1 to the power of 7 is 1, times negative x cubed over 64, plus blah blah blah. Okay, now if we simplify each term, the first term is 1, second term is going to be minus, so 10 times 1 divided by 4 is just minus 5 over 2, which is just minus 2.5x. So all you have to do is put into your calculator and simplify each one. The second term is going to be positive x squared. 45 times 1 divided by 16 is just 2.8125x squared. The last term is going to be negative, so 120 times 1 divided by 64 gives me minus 1.875x cubed. The next one will be plus dot dot dot. So we've got our first 4 terms. B, use your expansion to estimate the value of 0.975 to the power of 10, giving your answer to 4 decimal places. So what we're trying to use is, 1 minus x over 4 to the power of 10 to give us an approximation for 0.975 to the power of 10. Now, if we expanded and got all the terms, it will give us an actual answer. Obviously, if we're going to use our estimate, we're going to get an estimate. So 1 minus x over 4 is equal to 0.975, because we can get rid of the to the power of 10 in both. So that means x over 4 will be equal to 1 minus 0.975, which means x over 4 is equal to 0.025. If I multiply by 4, both sides, I get x must be equal to 0.025 times 4, which means x is equal to 0.1. Now that I know what x is equal to, I need to substitute x is equal to 0.1 into the binomial expansion of 1 minus x over 4 to the power of 10. So that means 0.975 to the power of 10 is approximately equal to, because we're only using the first 4 terms to get our answer, 1 minus 2.5 times 0.1 plus 2.8125 times 0.1 squared minus 1.875 times 0.1 cubed. We put this into our calculator, we get 0.77625. And if we round this to full decimal place, it's 0.776324 dp. Another similar question where we're calculating an approximate value. So write down the first four terms in the expansion of 1 plus 2x to the power of 8. So 1 plus 2x to the power of 8 is equal to 1 to the power of 8 plus 8 choose 1, 1 to the power of 7 times 2x plus 8 choose 2, 1 to the power of 6 times 2x squared plus 8 choose 3, 1 to the power of 5, 2x to the power of 3. That's which is just equal to 1 plus 8 times 1 times 2x. 8 choose 2 is 28 times 1 to the power of 6 is just 1 times 2x all squared is just 4x squared. 8 choose 3 is 56. 1 to the power of 5 is just 1. And 2x all cubed is 8x cubed. If I input this into the calculator, the first term is just 1 still. 8 times 1 times 2x is just 16x. 28 times 1 times 4x squared gives me a 112x squared. And 56 times 1 times 8x cubed gives me 448x cubed. Part B says, by substituting an appropriate value of x, which should be stated, find an approximate value of 1.02 to the power of 8. So 1 plus 2x to the power of 8 must be equal to 1.02 to the power of 8. So which means 1 plus 2x is equal to 1.02, which means 2x is equal to 0.02, which means x is equal to 0.01 when we divide by 2. So substitute x equals 0.01 into binomial expansion, which means I get 1.02 to the power of 8 is roughly equal to 1 plus 16 times 0.01 plus 112 times 0.01 plus 448 times 0.01. Sorry, squared, I put the square there, and cubed, yeah? Now if I put that into my calculator, I end up getting 1.171648. Okay, one last question that I want to go through is f of x is equal to 1 minus 5x to the power of 30. Find the first four terms in ascending power of x in the binomial expansion. So A is, so 1 minus 5x to the power of 30 is equal to 1 to the power of 30 plus 30 choose 1, 1 to the power of 29 times minus 5x plus 30 choose 2, 1 to the power of 28 times minus 5x all squared plus 30 choose 3, 1 to the power of 27 times minus 5x to the power of 3. That's blah, blah, blah. 1 to the power of 30 is 1. 30 choose 1 is 30. 1 to the power of 29 is just 1 times minus 5x plus 30 choose 2 is 435 times 1 times minus 5x all squared is 25x squared plus 30 choose 3 is a very large number, 4060. 1 to the power of 27 is just 1 times minus 125x cubed. That's dot, dot, dot. If I simplify, I get a 1. Take away 30 times 1 times 5x is minus 150x. It's a positive 1 next. 435 times 1 times 25x squared gives me 10875x squared. The last term is going to be negative 4060 times 1 times 125x cubed gives me 507,500x cubed. Plus dot, dot, dot. Use your answer to part A to estimate the value of 0.995 to the power of 30, giving your answer to 6 decimal places. So B is 0.995 to the power of 30 is equal to 1 minus 5x to the power of 30, which means 0.995 is equal to 1 minus 5x, which means 5x is equal to 1 minus 0.995, which is 5x is equal to 0.005. If I divide by 5, I get x is equal to 0.001. So substituting x is equal to 0.001 into the binomial expansion that I've done in part A, I get 0.995 to the power of 30 is equal to, approximately equal to, so curly equal sign, approximately equal to 1 minus 150 times 0.001 plus 10875 times 0.001 squared minus 507500 times 0.001 to the power of 3. If I input that into my calculator, I end up getting 0.8603675. And if I round it to 6 decimal places, I get 0.860368 to 6 dp. Use your calculator to evaluate 0.995 to the power of 30. So if I evaluate it, I get 0.995 to the power of 30. In my calculator, I get 0.8603841,919. So this is my actual answer. Calculate the percentage error in your answer to part B. So to calculate the percentage error, so percentage error is equal to actual takeaway estimate over the actual times by 100. So the actual answer is 0.8603841,919. Take away my approximate answer or estimate, which is 0.860368, all over my actual answer, which is 0.8603841,919, and I need to times by 100, which gives me an answer of approximately, because remember I had the actual answer is an approximate, which is equal to 0.00188. So if I round it, it's approximately 0.0019%. So it's a very small percentage error. So the binomial expansion is actually a good approximation for this.